Hello dear friends, how are you? Welcome to my channel. I hope you are all will be fine. I'm also fine, thank you. Let's start today topic. What is today topic? Today topic is about the carbon anion. What is meant by carbon anion? How can you define what? How can you draw the structure of carbon anion? How can you found how is the formation of carbon anion occur? How is the stability of carbon anion you can measure? So let's start the topic. Okay, first of all, you can define carbon anion is the all anion in which the negative charge is carried by a carbon are called carbon anion. At this topic is similar to the lecture that I before yesterday I teach you about carbon. This is I put its link in description box, so you can also search from there. What so let's start. What is carbon anion? All the anions, all the all the anions in which the negative charge is carried by a carbon are called by a carbon are called carbon anion. Carbanion. Is it clear? You can define carbanion is like this: all the anions in which the negative charge is carried by a carbon is called carbanion. All the anion should have negative charge. Anion should have negative charge. The negative charge is called anion. All the species, all the ions, anion you can define anions. All the ions that can move towards the anode in the solution is called anion. These all ions are be anion. So anion, it means that while anode has positive charge, while anode have positive charge. So all the ions that move towards that approach towards positive charge means that should have negative charge. Means all these ions that will have negative charge, they will they will approach to the anode. So all the ions, but those ions that have negative charge, but this negative charge is carried by a carbon are called carbon anion. Is it clear? This is the definition of carbon anion. So let's, what is the structure of carbon anion? The structure of carbon anion is like that. There is one orbital where two electron is present in carbanion, like that. Similar, like this is one carbanion, CH2 CH. This is one carbon anion. So how you how you can draw its structure? Its structure will be CH3. Its structure will be CH3C. This is one orbital, this is hydrogen, this is another hydrogen. Here in this orbital there will be one lone pair of electron. If there is one lone pair of electron in this orbital, in this empty orbital, and this free lone pair of electron act as a nucleophile, also act as a base, also act as a ligand in coordination chemistry. Is it clear? These carbon anion, this lone pair, the free lone pair, that are this negative charge that are carried by this carbon is called carbon anion. So this is the structure of carbon anion. Also carbon anion has sp3 hybridization. Hybridization is a sp3 hybridization, because here is one lone pair present and three sigma bond present, so sp3 hybridization will be formed. sp3 hybridization is be present. These are the hybridization and structure and definition of carbon anion. So let's start the stability of carbon anion. Are you ready? Okay, you can take screenshot or you can write on your notebook. Now I'm just cleaning the board because of lack of space. These are my initiation, these are my initial stage of lecture delivering. So uh, I have not yet too much facilitated. So I will be try my best that I uh, have done all the thing well. Okay, thank you. So let's take example. This is methyl carbocation carbanion. This is primary carbanion. This is 1 degree carbanion. This is 2 degree carbanion, second carbanion. This is tertiary carbanion, 3 degree carbanion. So let's explain the stability of carbon anion, or let's explain the reactivity of carbon anion. Which one carbon anion will be most reactive carbon anion, or which one carbon anion will be most stable carbon anion? How can you draw the order of its stability or its reactivity? Let's start. Okay, what is meant by carbon anion? Carbon anion are those ion having negative charge, having anion. And you know that anion means it have negative charge, and negative charge you also mean that it has a high charge density, and high charge density means more number of electron is present, am I right? Okay, yeah, I am right. Okay, negative charge, where here is negative charge, here is negative, in all cases all carbon have negative charge. So negative charge means that there is high electron density. It means that this electron density show the reactivity towards electrophile are those species that have the deficiency of electron, very much deficiency of electron, or you can say that as electrophile are those species that can accept electron, or you can say that electrophile are those species that act as a Lewis acid. Am I right? Yeah, I am right. Here in all the cases hydrogen hydrogen all the cation can attack on hydrogen on electrophile. Yeah, it can be attack on electrophile, hydrogen is a hydrogen has no electron, here is electron deficiency, so it is called electrophile. In all the cases, all the carbon anion attack on electrophile. So which one carbon anion will be attack more easily on the electrophile, which show the stability and reactivity of the carbon anion? Here in case of 3 degree amine, here is three similar methyl group or electron donating group attached. This means that will increase the electron density more further on the carbon anion. Carbon anion has also greater electron density, but when electron donating group are attached with carbon it will increase further the electron density. That means that it will increase further the reactivity, it will increase further the possibility to that hydrogen will attack on this carbon will easily. But in case of secondary amine, here is only two electron donating group attached with carbon anion. It means that this here is less electron density as compared to the 3 degree carbon anion. and because here is only two carbon anion, two methyl group, two electron donating group, it will not enough capability, it will not enough capacity that increase the number of electron or electron density on the carbon anion like in case of 3-degree amine. So it will show less reactivity towards electrophile as compared to primary, it is compared to tertiary carbanion. Mean tertiary carbanion is very reactive, very less stable towards the primary carbon, towards the electrophile, while secondary carbanion is less stable as compared to 3-degree amine, and is more stable and less reactive towards electrophile as compared to 3-degree amine, 3-degree carbanion. While primary amine, here is only one electron, here is only one electron with driving group attached, so here is only one group that show the increase in the electron density on the carbon anion, but it also means that here is not enough increasing occur in electron density as like in 2-degree amine or in 3-degree amine, in two, sorry, not amine, how I did use the word amine. So here in 1-degree carbonine, here is only, here is not enough increase occur in electron density as like in 2-degree carbon ion and 3-degree carbon ion, because here is only one electron group. It means that it will show very less reactivity toward coming electrophile. It also means if there is if there is less reactivity, it means this is more stable. But in case of simple methyl carbon ion, it is more stable, it is very less reactive, because here is all only hydrogen, not enough, even no alkyl group or no methyl group is attached, so no electron donating group attached, so it will show it have very less electron density on this carbon. But in case of 1-degree amine, it has more electron density as compared to this first, as compared to the carbon ion, this carbon ion. But secondary carbon ion, it has more electron density than primary carbon ion, while tertiary carbon ion has more and more electron density than secondary amine. That means that more the electron density, more will be show reactivity towards electrophile. It means that the reactivity order will be like this, the reactivity order means this will very reactive, this will less reactive, this will less reactive than this one, and this will very less reactive. If less reactivity means more stability, means the stability order will be like that, stability order, it will be more stable than this one, this one will be more stable than this one, this one will be more stable than this one. So the stability order will be C3 will be more stable, CH3 negative will be more stable than primary, primary will be more stable than secondary, secondary will be more stable than tertiary. The stability order will be like that. I hope you will be clear. Also resonance resonance can also explain the stability of carbanion. How? Let's take another example. So let's take another example like that, that is CH2 double bond CH single bond CH2 negative. Yeah, one compound is that and another compound is that CH2 CH2 not like that. Another compound is the CH2 like that. That is phenyl methyl carbanion. That is methyl carbanion. Methyl phenyl carbanion. And this is primary carbon, or you can say benzyl carbanion, benzyl methyl carbanion, and this is the vinyl carbanion. Which one will more stable? Here is in both cases the resonance are involved. Here resonance will be like that, if this carbon and this negative charge, when this negative charge come here make double bond, then this double bond will be shift here and resonance will be established like that. That will be formed like that, CH2 CH double bond CH2 and negative charge come here. So it will reversely can form that one. So mean that negative charge will be dispersed. But in case of mean two resonating structure is formed, but in case of here what will be the situation? Here the situation will be like that. Let's take the correct position of the camera. Okay, what will be the situation? Here situation will be like that. This is CH2 negative. If this negative will make double bond here, so this double bond will be shift here. It will make like this structure. This is double bond CH2 negative charge double bond double bond. If this negative charge make double bond here, so this negative charge will be shift here. So it will become like that. Double bond CH2 double bond negative charge. This negative charge shift here and this double bond will be shift here. So to negative charge to lone pair, it will be like that. It will form like that. It will be formed like that. How? This will double bond CH2 negative charge double bond. When this double bond, when this negative charge make double bond here, this negative charge will be this double bond will be shift here and make the original position of the compound like that. That will be CH2 negative. Means here is electron density dispersed more as compared to this complex, as compared to vinyl carbanion. So it means that more the electron density, more the dispersion of electron density, more will be stability, or you can say less will be show reactivity. It will show less reactivity because more electron dispersed here. But here is not charge density less dispersed, here is charge density more dispersed. So the phenyl methyl carbanion or methyl carbanion will be more stable than this one vinyl carbanion, or you can say that vinyl carbanion will be more reactive than phenyl methyl carbanion. Is it clear? That is the reactivity, that is the stability order. This is the stability of carbanion, reactivity of carbanion. I hope you will be cleared very well. These are the today topics. If you have any confusion, if you have any misunderstanding, you can ask me, and if you can ask me in comment section, as well as you can ask me in person, my personal WhatsApp and in my Gmail. I put it in description box, you can got from there. Okay, thank you. Please support me, subscribe my channel. I feel very happy that my students are supporting me. Okay, thank you, best of luck. My best wishes are with you. Thank you, bye, best of luck.